Okay, so we are doing, should have wrote it up there. We're doing, what is it? Practice test number 2, right? Practice test number 2. And it covers sections 1.1 to 1.4. Alright, just so that if you watch this on the video, you know what we're doing. Alright, so this says to multiply, right? So it's just distributive property. You take this thing on the outside, that's to the 7th power right there. Kind of looks like it could look like a 2, but that's a 7 right there. So you just distribute. You take this thing and you multiply it by all 3 of these. Okay, so let's go ahead and do that. Let's multiply the first ones together. So first of all, 8 times 4 is negative 32. Good. And then you got a times a squared, and then x to the 7th, x to the 6th. What's the rule? What do we do with the exponents here? Add them up. That's right. So you take x to the what? 13? Okay, good. Everybody good so far? Now we do the same exact thing to the second term. Take that 8a x to the 7th times the second term. So 8 times negative 5 is negative 40. Now this doesn't have an a, so we still have to multiply by a, right? So it's just an a. Multiply the x's together, and that's x to the 12th. Remember, you add the exponents. It's a multiplication problem, isn't it? But you add the exponents. That's the rule. Alright, 8 times negative 5 again, negative 40. And then a times a squared. And this just has an x to the 7th. That doesn't have an x, so we just keep it x to the 7th, and that's it. So it looks like a long, complicated answer, but it's actually a pretty straightforward multiplication problem, isn't it? Is that the answer that they have there? Okay, good. Alright. So far, so good. Let's keep going. What's the next one? 13. Let's make this a little more colorful. 13. Oh, long division. Everybody's favorite, right? Tell you what, excuse me, I'll write it as a long division problem. They write it as a fraction. But remember, the top one goes in the box, right? So that x squared plus 7x plus 9 goes inside the box here. X squared plus 7x plus 9. Now, I think on that quiz, they might have had like x cubed and then x and then a number. Do you remember that? You got to make sure it's all filled in. So if this has an x squared, you have to have an x, and you have to, and then your constant. Okay. So far these have been pretty easy. I can't remember off the top of my head on the test if it's just like this or if you have to fill in one. But what if this was like an x cubed? What would you need to fit in between an x cubed and an x? X squared. And how do we fit in an x squared without changing the value of it? Make it a what? X squared? 0x squared. That's right. We would make it a 0x squared. Now we don't have to do that in this case, do we? Because I already have x squared, x to the first, and then a constant. Technically that's x to the 0, right? Well, if it's anything, like if I had, I'm just making this up, if I said x cubed plus 2x minus 3, alright, and then I had like x minus 1. Let's just say that, okay? I can't just start dividing right now because look, I got an x cubed and I get an x to the first. I need to slide something in there, don't I? Alright, I got to go in order. So it's kind of like filling in a place value. So if I have x cubed, I have to have an x squared. Alright, so what would that be? That would be x cubed what? Plus 0x squared. So I didn't really change the value of it, right? I just added a 0, which didn't really change it, but it did give me that place value. It gave me that x squared place value. Does that make sense? Just in case you have something like that on the test. Alright, just make sure that you do slide that in there. Do we have to do that with this problem right here, though? No, we don't. Alright, so we're good to go with this. So let's do this a little bit quick. X goes into x squared, or x squared divided by x is x. Okay, you put a minus and put a parentheses. Make sure you follow these steps. I think it's very important. You put the minus, put the parentheses, then we can fill in. And if you wanted to, you could put this in parentheses just to remind you that you have to do what to that x in this thing. Distribute it through, multiply it through. So we've got x squared and then plus 3x. It's very important that you put that minus there. Okay, back in the day when you were doing regular long division problems, a lot of people, myself included, just wouldn't put the minus there because you already knew to subtract, right? But in this, it's a good reminder to put that little minus there. So x squared minus x squared is 0. 7x minus 3x is 4x. Drop down the next number. How many times does x go into 4x, or 4x divided by x? It's 4, so I put a positive. It's positive 4, right? So I put a plus 4. All right, put a minus, put a parentheses, and then multiply. 4x plus 12. Subtract, that's a 0. 9 minus 12. Okay, remember that negative is being distributed through this thing. That's why I put the parentheses there. 9 minus 12 is negative 3. Well, x doesn't divide into negative 3, so that's our remainder. So we write our remainder minus, right, since it's a minus right here, we put minus. If this came out positive, we'd put a plus there, okay? And then, Malachi, would you say 3 what? Over x plus 3, right? Take your remainder, put it over whatever you're dividing by, and that's how you write your answer, just like that. We okay with that? Alright, it's not too hard, is it? It's starting to look a little more normal, like regular long division. First, when you see this, it looks real crazy, but after you do it a few times, you start getting the hang of it, I think. Alright, did anybody write those numbers down? I have to keep going back up every time. So 15. Somebody write those down so I don't have to go up all the time. 15, 16, 19, 20. Should be able to remember that, but my memory's terrible. I can't remember anything anymore. Alright, 15, is that right? See, told you, I just said it like 2 seconds ago and I already forgot. So it's 15. Alright. Factor, good. Factor by grouping, and they tell you how to factor. And on the test, I'll tell you also, group it this way. So that'll give you a good head start, because at least you know how you need to go about factoring. And then plus 24 b cubed. Alright. Well, you got 4 things here. Most likely, in almost all of these, we just group 2 of them together and then group another 2 together. And it works out pretty good, I think. We could probably just group the first 2 together, couldn't we? Like this. Now, you got to be careful, though. Remember doing this? We've done this several times, not just once or twice. I think we've done it at least 3 times. Where you're going to group these together, but watch. If I put a parentheses here, you got to be very careful. Because if I do this, because remember what this is. This is a plus 24, isn't it? But if I put a parentheses around this, what did I just do? By grouping this, yeah, that actually made it a negative 24, didn't it? But it needs to stay a positive 24, so what am I going to do? Change that to what? Negative. See what I just did? So really, by putting the parentheses here, it's still minus 18ab squared, which is what it was originally, and now it's also plus 24b cubed when I distribute that negative. So now it's exactly how we wrote it before, isn't it? All right, it's the same values. Did you catch that? That's the hardest part, I think, about that problem. That's the part that gets people messed up the most, was what I just did right there. So make a little mental note to yourself. Even in your notes, jot a little note to yourself and say, remember to change that sign. Now, you only do that if that's a minus right here. If this was a plus and you put a parentheses around here, a plus doesn't change the signs, does it? So you don't need to worry about changing anything if this was a plus right here. But if it's a minus, you need to do that. Now, let's go through. We're going to factor by grouping. I've got this parentheses right here, and we're just going to do a regular greatest common factor. So look at 15 and 20. What's the largest number that divides into 15 and 20? Okay, a 5, right? And what about the a's? A squared. What about the b's? No, because there's not a b in common with both of those. So that's our greatest common factor for this parentheses right here. So let's figure out what's left then. Remember, if we factor it out, we're just dividing, right? Taking this and dividing it by this. So 15 divided by 5 is 3. A cubed divided by a squared is a. Minus 20 divided by 5 is 4. A squared divided by a squared is 1. And you have a b left over. Just leave it like that. I know I'm going a little bit quick right now, but you always got the YouTube. You can go back, pause it, rewind it, listen to it 2 or 3 times if you don't catch me the first time, okay? Minus 18 and 24. What's the largest number that goes into both of those? 6. Okay. And what about the a's? Nope, there's no a here, so I can't factor out an a. But I can factor out what? A b squared. Let's see what's left over. So 18 divided by 6 is 3. A, and then that's it, right? Because b squared divided by b squared is 1. Put a minus. Okay. 24 divided by 6 is 4. And then b cubed divided by b squared is b. Alright, so all I did was 2 greatest common factors, okay? Wasn't that big of a deal. Now we got to do 1 more greatest common factor. Don't stop right there, because this is not completely factored, because you got a minus sign. You got this minus this, so it's not completely factored. We want something times something. That's not what we have here, is it? So I got to do that. But if you look at it, what's happening? I got something in common with both of these, don't I? Everybody see that? Look at this. That's one term. And look at this. That's another term. Do I have something in common with both of those terms? Absolutely. What is it? 3a minus 4b. Good. Alright, so that's in common with both of those. Now, if I take this whole thing divided by 3a minus 4b, what am I left with? 5a squared. Now, notice what I did. I didn't put a plus or minus in between here, did I? It's being multiplied. If I factor it out, then I just put a multiplication. There's no plus in here. I've seen some of you guys do that. Minus what? Factor 3a minus 4b out of this thing, and I get 6b squared. And that's your answer right there. Now it is factored. I got one thing times another thing, don't I? There's no plus in between those two things. So now it's completely factored, and I'm good to go. Alright, again, if I went a little fast, go back on YouTube, watch it, and rewind it and all that kind of thing. Yellow, I thought I clicked blue. There we go. 16 was the next one, was that right? Okay. Alright, trinomial factoring. Okay, when I say trinomial factoring, that's one of those factorings where you just put the two parentheses and you find, you know, it's kind of like the backwards of the FOIL method, isn't it? Alright, so we got to figure out what times what is 6x squared. We got a couple choices. We got 6 times 1, and what else do we have? Yeah, 2 times 3 or 3 times 2, right? What about 25? I got a couple choices there. I got 25 times 1, or I have what? 5 times 5, right? The signs make it real easy. What are my signs going to be here? Plus and plus, right? Because they have to multiply to be positive, add up to be positive, so that's pretty simple. So what do you want to try? Let's try 3 and 2. Again, I haven't looked at the answer. I'm not sure what it is. This is just how I'm going about it. And I would probably try 5 and 5. Alright, so how do we know if that's right or not? Well, we know the first is right, you know, because we put 3 times 2 because it was a 6. We know 5 times 5 is 25. How do we know if this is correct? Well, we take the outside, which is what? 15x, and then we take the inside, which is 10x. We add those up. Lo and behold, 25x. I was right on my first shot, wasn't it? Okay. And there it is. That's how you factor a trinomial. Sometimes if you don't pick the right numbers, if you don't put them in the right order, sometimes you got to try it 2 or 3 or 4 times. Okay. Sometimes you just get lucky, get it right the first time. Right? And we kind of got lucky there. Okay, good. What were the next ones? 19 and 20, is that what it was? 19 and 20? Okay. I did. My memory's not as bad as I thought, I guess. Alright. Sum of 2 cubes. Ah, this is everybody's favorite, right? Tell you what, I saw in that quiz several people just leave this completely blank. There's no excuse for that. I'm not going to say who it is because I don't even remember. But I do remember several people, I'd say at least 3 people, just left it blank. There's no reason to leave this blank. All you got to do is memorize a little formula. Okay, that's up to you. Okay, anybody, if you put some time and effort into this, can memorize the formula. Let me write down the formula so just a quick little review. This is a sum of 2 cubes. Everybody, I'll tell you what, let me scooch this down a little bit. Let me just put it right here. Everybody should be able to memorize this. Alright, I've gone through it a bunch of times. Probably 5, 6, 7 times I've actually done this for you in class. Alright, it's up to you to take hold of this and remember what I do. First thing, let's do the signs. I had a little trick to remember the signs. What was that trick? Same, opposite, positive. SOP, SOP, whatever you want to remember. So this is the same sign as this. This right here is the opposite sign of this. And this one's always positive. Let me scooch this over, give myself some more room. Okay. Alright, so we got to remember what goes in here. This is just a matter of memorization. Okay, you just have to memorize it. There's nothing else I can do. You can't tell me, there's no way I would accept you saying, well, I just don't know how to do it. No, just memorize it. Okay, I can't accept the fact that you can't know how to set this thing up. It's just a matter of memorizing it. Okay, you can do it if you put the time and if you put the effort into it. And if you leave it blank, it's telling me that you didn't put any time and you didn't put any effort into it. That's Would you agree if you're a teacher and you've been going through this many times? Yes? No? Nobody's going to shake their head? Nobody's going to call any of their fellow students out, right? Okay, so what's going to go right here? A squared, and right here, b squared. And what goes in the middle? ab. All right? So, at the very least, you should memorize this thing right here. Now, whether or not you can take this problem and turn it into this, maybe is a different story. Okay, but everybody, without excuse, can memorize this and at least write this down. Would you agree with that? Yeah, I think everybody in here can do that. All right. So let's figure out how we're going to get from this thing to this thing. Because look, this is a cubed, something cubed. I don't see anything cubed right here. Or do I? Yeah, I actually do see something cubed, don't you? What about 27? What's cubed to give you 27? 3. Now, what's cubed to give you x to the 12th? X to the 4th, that's right. So look, that thing right there is being cubed. So yeah, sure enough, we do have something that's being cubed, don't we? We have 3x to the 4th. Because 3 cubed is 27, x to the 4th cubed is x to the 12th. Alright, so this is acting like what in my little formula here? The a, the 3x to the 4th. So anytime I have an a, I'm going to throw in 3x to the 4th. What I'm doing right now is probably the hardest part of the whole problem, is just figuring out how to get from here to here. That's probably the toughest part of this problem. Everything else is just either memorize a formula, just plug stuff in. This is the part that takes a little bit of thought. Plus, now what's being cubed to give you this? Right, 4 cubed is 64. And if you don't know that, use your calculator. Punch in a few numbers just to see if something cubed is 64. Try 2, try 3, try 4. Right, and you'll find out 4 cubed is 64. Yeah, and you could just put a cube root in there, okay, if you know how to do that on your calculator. And this is going to be what? Y cubed. See that? Remember the rule? Exponent to another power, you multiply the exponents together. So 4 cubed is 64. Y cubed, right? What do you do with the exponents? Multiply them together. That's y to the 9th. So that is exactly the same as this. Everybody with me? So this x, in this little formula right here in the box, this 3x to the 4th is acting like our what? A. This 4y cubed is acting like our b. So all we do is just plug this in for a and plug this in for b. Alright, so here's our little formula. So let's do it. Give myself a little more room here. Put the signs. Oops. Okay, now the a and the b go here. Remember, this is the a, so that just goes in there without doing anything to it. And the b goes right here. That's our b. Now, this takes a little bit of math. Okay, not much, but a little bit. So we take the a, and what do we do with that a and put it here? Got to square it. So this is our a, isn't it? So we just have to square that thing. So what's 3 squared? 9. What's x to the 4th squared?
X to the 8th.
To the 8th, right, because remember, when you take an exponent to another power, you multiply the exponents together. Alright, so that would be x to the 8th. Okay, that's the a squared. I always like to go over here to the b squared. Since I'm on this roll, right, with squaring things, let's do this and put it in for b and square it. So I got to take 4 squared, which is 16. And I take y cubed squared, which is y to the 6. Good. And now, what do I do here? I take the a, multiply it by the b. So I take this number and multiply them together. So 3 times 4 is 12. Alright, hopefully all that, because that was like, what was it at? 18 something before it skipped? Yeah, look at that. Anyway, I hope it was recording. Well, you took notes on this anyway, didn't you? Alright, what are we doing? One more, right? 20? What color do you want? Anything? Have we tried this green before? Which one? That one? Is that going to be too dark? Can you see that alright? Okay. Alright, so what are we doing? 20, right? Oh, substitution. Alright. 25z to the 4th minus 5z squared minus 6. Alright. Remember that trinomial factoring we did earlier? Where it was x squared, x, and then a number, a constant? Well, this is not exactly that, is it? But it could look like that, couldn't it? This is kind of like our x squared, this is kind of like our x, and this is kind of like our constant. Well, it is our constant, right? But it would be really nice, instead of this being a z squared, it'd be really nice if this was just a what? An x. Okay, or whatever. It could be any letter, but it'd be nice if it was just one variable, right? Then it would fit that trinomial factoring, mold that we've learned how to do. So what I'm going to do is I'm going to say let x equal what? Z squared. Good. So that's going to be our substitution. So what we're going to do is we're going to rewrite this, but we're not going to have z to the fourth and z squared. We're going to have x squared, and we're going to have x. So this is just going to be 25. Now remember, if x is z squared, if I square the x, or if I square that, what does that give me? Z to the fourth. You see that? So it works real nice. So this is, I can just write x squared minus 5. What did I say z squared was equal to? Just x. Now look, this looks a lot better, doesn't it, than factoring something like this? So the only reason I did this, just because it works, it's a little easier to see and recognize. Alright, now I can do a regular trinomial factoring like we did earlier, and once we're all done, then I can just replace that z squared back in for that x. Alright, so let's see what we can do. Let's do it with the x's and then see what we've got. 25. Let's do the signs first. I always like to do the signs. Plus and minus, because it has to multiply to be negative, add up to be negative. Alright, so one has to be positive, one has to be negative. 25. I could go 25 times 1, but I'm going to go 5 and 5. I could go 6 and 1, 3 and 2. Let's go 3 and 2. Alright, let's see if that works. Okay, it might not. How do we check? Check the outside and the inside, because it's backwards a FOIL method, right? So what's the outside? Negative 10, and the inside is positive 15. Well, that gives you a positive 5. That's not positive 5. But I'm only off a negative, right? So, yeah, I would say a good choice is just switch the signs. Make that negative, make that positive. Now let's see what we get. Positive 10 on the outside, negative 15 on the inside. Sure enough. I only had to try it twice, didn't I? And I got it right. But I'm not finished. I'm not going to circle that, because that does not equal that, does it? So what I have to do is just replace that x with what? Z squared. And that's as easy as it could be. So it's 5z squared minus 3, and then 5z squared again, right? Because x is z squared, plus 2. And there you go. That's your factoring right there. Substitution's not too bad, is it? All right. I mean, they've rigged this thing for you, didn't they? Because they made sure that this thing was being squared, to give you that. But that's all right. It's just practice, okay? They're just doing practice. All right. We got a few minutes left if you want to do another one. Is there something else on there that we haven't done? Because you're taking it to the 5th power. Anytime you take a negative to an odd power, it's always going to be negative. Because if you watch, look, if they're paired up, anytime the negatives are paired up, you're always going to get what? Positive, okay? But if you just have one negative, or let's say 3, let's go 3. See, these two of them always pair up to be positive, don't they? And if it's an odd number, they'll all pair up except for that one on the end. Right, so that's always going to be negative. So anytime you have an even exponent, it's always going to be positive. Right, so if I had like negative 3 to the 8th, forget actually what the number is, just look at the signs. What's the sign of this going to be? I'm taking a negative 8 times, so they all pair up, don't they? They all have a partner, right? So that's going to be what? It's going to be positive. But if I had negative 3 to the 17th power, what's that going to give you? It's going to be negative, right? Because if I go to the 16th power, they all pair up. But then I always have one extra left over, okay? So to the odd exponent, it's going to be negative. To the even exponent, it's always going to be positive. 4, okay? What color haven't we picked? Blue. Which blue? Let's go different blue. This one. It's not much different, but...
I like blue.
I see these guys online doing this thing. There's this one guy that I've subscribed to on YouTube. He's a teacher and stuff. But he's always constantly changing. So if he did a problem like this, he'd probably have like 4 or 5 different colors all in that one problem. But so he's constantly going back. But I think I'm too lazy to go back and go to different colors all the time. So I just stick with one color for each problem. I guess it doesn't make much difference, does it? All right, which one are we doing? 4. There we go. 4. Alright, so they tell you what x is, and they tell you what y is. And they ask you to evaluate this thing right here. Absolute value. I remember when I first started learning algebra, for some reason, man, absolute value gave me fits. But now I look back on it, not because I'm like all smart or anything, but maybe it just wasn't explained to me that well. For some reason, I always thought absolute value just made the sign like opposite, right? But it doesn't. What does it do? It makes it positive. Now, there's one situation where it does make it opposite, right? So if the stuff in here was negative, then you would take the opposite sign, right? But what if the stuff in here came out positive? Then it would stay positive. That's right. Now I look back on it, it looks so easy, you know? But I don't know, back when I was doing it, I remember struggling with that. So let's do this. Let's keep the absolute value there. Let's plug in stuff for y and for x, keeping the absolute value. All right, don't forget about that. So it's negative 4 times y, which is 15, minus 7 times x, which is 12. Keep the absolute value. Look, don't do this. Don't say, oh, it's absolute value. Just make that positive and that positive. Okay, sometimes that'll work, all right? But you don't want to do that every time because sometimes it doesn't work. So I'm just going to go by the rules here. Negative 4 times 15 is, what did you say, Tiff? Negative 60. And 7 times 12, what's that, 84? Negative 84, good. All right, and I'll tell you what, well, normally I would do the whole thing at once, and I probably should, but I'm on a roll here, so let's keep going with this. What would this be? Negative 144, is that right? So negative 144. But it's an absolute value, isn't it? Now look, I kept the absolute value all the way down, didn't I? I didn't try to make everything positive too early. I waited till I got one number, okay, and then I applied the absolute value to it. So what's the absolute value of negative 144? Positive 144, okay? So make sure that that's the way you should do it. Now, technically, if you would have just made these positive right here, it probably would have come out to the same exact number. But you don't want to do that, though, because there are times where it's not going to work out for you. All right, so now let's do the rest of it. Minus, so it's 8 times y, which is 8 times 15. Somebody tell me what that is. What's 120? Okay, positive 120, right? Okay, but I got a minus in between, don't I? So it's minus what? 120. That 120 stayed positive, didn't it? You're like, well, wait a minute, it didn't stay positive. There's a negative in front of it. Well, the negative wasn't from the absolute value. The negative was because you're subtracting the two from each other. Make sense? All right, and then that's easy. What's that? 24? There's your answer right there. So if you just follow those steps, I mean, it's a little bit of writing. It's not that big of a deal, though. It only takes a few seconds. Doesn't take that long. Okay? 6? Okay. What I would do, listen, this is what I would do if I were you. And I would take, ooh, let's go this tan color. Cappuccino is what they call this. Probably looks ugly. What I would do is take this test from scratch and time yourself, because you're only going to have the class period to work on it. So try to get this thing done in 40 minutes. And I would keep doing it until you can finish it in 40 minutes. If you can do that, you should probably not have much trouble on the actual test. The test will look almost identical to this, just the numbers are going to be different. Okay, same kind of problems. It's not going to be anything real tricky to it. Look at this. Is this a multiplication problem? No, it's not a multiplication problem because you got a minus in between these two parentheses. I've seen on your homeworks when you passed them in, I've seen people try to distribute all this stuff and do multiplication. It's not. It's a subtraction problem. All you have to distribute is this negative. All right, that negative has to be distributed, and that's it. So this parentheses right here is almost meaningless, isn't it? That first one, because there's nothing out in front of it. There's nothing to multiply. So I just keep it like this. Now look at this. This negative distributes through here. It just changes the sign of everything. So that's a plus 5n squared. It's a minus 6n to the 5th, and it's a minus 18. And now you just add like terms. N to the 5th, right? So 4n to the 5th minus 6n to the 5th is what? Negative 2n to the 5th. I like to get rid of them. And then n squared, 8n squared plus 5n squared is 13n squared. That goes. And then we got just regular numbers. Positive 14, negative 18 is negative 4. That's it. That's all there is to it. Just have to realize to distribute this. Distribute the negative, okay? This is not a trinomial times a trinomial. You've got something in between. You've got a minus sign. What if it was a plus sign? Would you change all the signs inside of this? No, really, if it was a plus sign, you wouldn't even need those parentheses at all, would you? You just add up all the like terms. But you got a minus, and that's being distributed. You're good to go. We okay with that? All right. This is all being recorded. All right. Over 30 minutes. You don't have to sit there and watch every single one of them. But if there's a particular one that you didn't quite get in class today, you're like, man, I need to go back, listen to it maybe 2 or 3 times, then go ahead and do that. It'll be up online this weekend, so make sure you do that. Remember, the test is on Monday. The test is this Monday. So make sure that you are prepared. Everybody okay? How do we feel about it? Yeah. I hope so. Okay, good luck on it.